In the previous section, you saw all of the data types available to you. So you'll have code where you use integers and decimals and strings, etc. And from time to time, you'll want to write code that uses more than one data type in the same line of code. For example, you might want to take an integer value and multiply it by a decimal value. To do that, you're going to need to convert one data type to another. There are two types of conversions: widening and narrowing. In a widening conversion, the new data type is capable of storing all of the values that can be stored in the original data type. So for example, if you convert a 32-bit integer to a decimal, that conversion will always succeed because the decimal can store everything that a 32-bit integer can. And because there's no risk of data loss, the compiler will make the conversion for you automatically. You actually don't have to write code to make a widening conversion happen. The other type of conversion is a narrowing conversion. In the narrowing conversion, the new data type is not capable of storing all of the values that can be stored in the original data type. So for example, if you convert an integer to a byte, there could be data loss. And because of that, the compiler will not automatically make the conversion. You'll need to make the conversion yourself in code. So you don't have to write code to do a widening conversion. You do have to write code to make a narrowing conversion. In general, you should probably make your conversions explicitly anyway, because your code is more readable and understandable. Let's look at three options you can use for converting from one data type to another in your code. The first option is to use a cast operator. So in this code we have two variables. One's a short, the other's a byte. We want to add them together. Now when the C# compiler sees short value plus byte value, by default it assumes that's an integer. And because we want to store the addition to a short variable, we use the cast operator, which is the left parentheses, short, right parentheses, to tell the compiler, add the two variables together, and then convert that result into a short, and then store that in a short value. Now the cast operator is specific to C#. Another option is to use the convert class, which is part of the .NET framework. And the convert class provides a conversion method for each data type. So in this code we have a variable long value, which is a long, and we want to convert it to a single. So we call the toSingle method of the convert class and pass the long to it. And the third option is to use the parse method, which converts a string to a data type. So in this code we want to convert the long to the single. So we first convert the long value to its string representation and then use the parse method of the single structure to convert that string to a single. Well, obviously if you have the variable as a long and you want to convert it to a single, you'll use convert.toSingle of long value. You won't take the long, convert it to a string, and then convert it to the single. But if you have string representations to begin with, then the parse method is the way to go. In the previous section, we talked a little bit about converting from objects to specific data types. And this is an important concept that you really need to understand. There are two types in the .NET framework: value types and reference types. A variable that contains a value type directly stores its values. And those values are stored in the stack, which is a pool of memory allocated by the runtime. And because you're declaring value types in your code, the runtime knows to allocate the proper amount of memory for them. And this is efficient because the space has already been allocated on the stack, which again is a piece of memory. All of the integer data types, floating point, decimal, Boolean, these are all value types, and they directly store their values. The other type of variable is a reference type. The reference type does not store the value, it merely stores a reference to where the value is. And these are stored in a heap. And this is a pool of memory whose size is dynamic. If you use a reference type, you're not specifying ahead of time how much memory to reserve for it, so the runtime will allocate memory as needed. The actual value you're storing in a reference type variable is stored in the stack, but the variable itself contains a reference to the value. And that reference is used to find the value each time you reference the variable in code. and this is less efficient than using value types. Reference types include strings and objects, as well as classes you create. Strings and objects are reference types, as well as classes. Two terms that you'll see often when talking about value types and reference types are boxing and unboxing. Boxing is when a value type is converted to a reference type. So the framework copies the value to the heap and brings back a reference to the value. So if you store 7 in an object variable, that's boxing. 7 is an integer, that's a value type. You're converting it to a reference type to store it in an object. Later on, you want to read the value of the object, and this is known as unboxing, because the reference type is now converted to a value type. So the framework uses the reference to copy the value back into a value type. So you have 7 stored in an object. The .NET Framework has a reference to the 7, goes and retrieves that, and then brings that back. So it's boxing when you store a value type into a reference type. It's unboxing when you retrieve the value of a reference type and put it into a value type. And both of these are less efficient than using value types to begin with. Now there are obviously times when you'll use boxing and unboxing. For example, if you're converting an integer to a string to display it on the screen, you're going to have to convert between a value type and a reference type. So the takeaway is not to never use boxing and unboxing. The takeaway is to understand how value types and reference types work and write the most efficient code that you can. Let's go see a demo of converting from one data type to another. I'm in the sample application, and I'm looking at some code that's going to convert data types. First, I create a variable called UnitsOrdered, that's an integer, and I store 100 to it. Next, I have a variable called UnitPrice, that is a decimal, and that stores 24.5. Then I create a total amount variable, which is also a decimal, and I want to multiply units ordered by UnitPrice to get the total amount. Units ordered is an integer, unit price is a decimal. I can always multiply these two together. 100 times 24.5 is 2,450. There's no risk of data loss, and so C# will compile this code. I can build the application, and it builds fine. Let's look at a different example. I'm going to comment this code and uncomment the code below it. Now, units ordered is still an integer, unit price is still a decimal, but this time the total amount is defined as an integer. Well, if I'm going to multiply an integer times a decimal and store it in an integer, there could be data loss, because a decimal can contain fractions, but the integer does not. So watch what happens when I try and build the solution. The compiler tells me that I cannot implicitly convert a decimal to an integer. Data loss could result. So the compiler on its own will not put me in a position of losing data. Now, if I want to, I can certainly tell it to. I can use a cast operator and convert this to an integer, and now the code will compile. If I want to lose data, and I purposely choose to lose data, the compiler will let me. But it won't put me in a position where it chooses to lose data. Okay, let's run this application and look at some additional examples of converting. Let's look at widening conversions. I'll press K. And we're going to look at 3 ways of doing widening conversions. First, we'll look at using conversion operators, then the convert class, then the parse method. So first I'll step into the conversion operators method. We're going to create variables using a variety of data types. Then, in pairs, we're going to convert one to another. First we store a value to the byte variable, then to the short variable, and then we want to add them together. And to do that, we need to cast to a short. Now the reason we need to cast to a short is that C# by default, when it sees short value plus byte value, assumes that this is an integer. The default for adding two numbers together is an integer. So we want to take the addition of these two and convert it to a short. And then when we do that, we can add the two together and look at the results. In this next example, we have a short and an integer. And here, we can directly convert the short value to an integer using the int conversion operator. And then we can add the integer to what is now an integer and display the results. Similarly, to convert an integer to a long to a float to a double, and a double to a decimal. So I'm going to right-click here and run to cursor, and that will execute up to where I just clicked and pause execution. And here you can see that we've added an integer to a long and a float to a long. And interestingly, when we convert from a long to a float, notice that the decimal places disappear. And this is because of the way floating point numbers are stored in memory. So you'll need to be careful converting an integer, which has no fractions, to a floating point which does. And also, notice when we convert from a float to a double, we gain some decimal places. Now, float value has 3 decimal places, double value has 4, and when you add them together, after converting the float to a double, when you add them together, that number is accurate to the first 3 decimal places, and then after that, there are some numbers there you may not have expected. And again, that's because of the way floating point numbers are stored in memory. So you'll just need to be careful converting from one floating point to another, or from the integer to the floating point. Let's see what happens when we add the double and the decimal. Here we maintain the same number of decimal places. So when converting from a floating point to an integer, or from the float to the double, watch out for the decimal places. That's the tip there. We have a couple more examples. Here we have a variable that's a decimal and a string, and we're going to convert the decimal to a string and then add the two strings together. And that just takes the string representation of the decimal and adds it to the end of the first string. And finally, we have a character and a string, and we can convert the character to a string and add the two of them together, and that has the results you'd expect adding the letters together. And that's concatenating the two strings. Okay, we just saw conversion operators. Let's do the same thing using the convert class. Let's step into this code. We have the same variables, and now we're going to use methods of the convert class. So again, we want to add the short and the byte, which C# by default treats as an integer. We'll convert that to int 16 and store that into the short variable. And we get the same results as we got before. Do the same thing with the short and the integer. Call convert.toInt32 on the short value. That converts it to an int. We add that to the integer, and we get the expected results. To convert to a long, we use toInt64. To convert to a float, we use toSingle. And this is a good illustration of how the names of the data types in C# are not always completely the same as the names of the structures in the .NET framework. And you'll just have to get used to that. That'll come with time. To convert float to a double, we use convert to double, convert to decimal to convert to a decimal data type. We'll step out of that, and we see the exact same math as before. And finally, we're going to look at the parse method. We'll step into this, same variables, and now we're going to use string representations so that we can use parse. So we have a byte, we have a short, and just to be different, I've explicitly converted that up front to a short. To make sure that C# understands that this is not an integer that then gets converted to a short, I do the short up front. Then I can add the short value and the byte value together, which will wind up being an integer, convert that to a string, and then parse that into a short value. Okay, and the results are the same. The next example, again, the short value, the integer. Take the short value, convert it to a string, use the int32.parse to convert it to an integer, add it to this integer, and the results are as expected. And so on with int64.parse, single, double, decimal.parse. So 3 different ways of doing essentially the same thing, using conversion operators, using the convert class, using the parse method of the data types. Wind up with the same results, 3 different ways to do it, and you'll choose the one that makes the most sense in your code. Now let's take a look at value and reference types. I have 2 variables. Object 1 is an object. Number 1 is an integer. When I store 77 to number 1 now contains the value 77. Number 1 is an integer data type. That's a value type. It directly stores the value. But when I store that same value to the object is a reference type. So object 1 now contains a reference to where the value that it contains is stored. So right here, I have boxed. When I now want to display the value of object 1, the runtime needs to go get that value and then convert it into a string. That's unboxing. Next, I want to display the value of object 1. Well, first I have to go get the value of object 1. So the runtime uses the reference in object 1 and goes and retrieves the value of 77. That's unboxing. And then to display that, the runtime then takes that value and converts it to a string, which is actually boxing. So in this line of code here, there's unboxing and boxing occurring. And I see the value of 77. Next, I create a variable called string1, which is a string. String is a reference type. And so I want to take the value of number 1, which is 77, convert it to a string, and store that in string1. So I'm taking a value type, converting it to a reference type. That's boxing. Now when I want to display that, I need to know what the value is in string1, which is 77. So the runtime now needs to unbox, take the reference from string1, go find the value of 77, and bring that back and store it in string1 for the purpose, in this code here, of displaying the value. So again, the takeaway is not to avoid boxing and unboxing and using reference types, but to be aware of it and keep the number of times you box and unbox to a minimum. Let's take a look at some additional ways you can store information. And these aren't literally variables, but they serve a similar purpose, and that is as a place to store information. Constants get declared like variables, but they differ in that their value cannot be changed in code. So you can think of them, if you want, as read-only variables. And a perfect candidate for a constant would be, for example, the value of pi. You define it once, it doesn't change, and then you can just use it over and over again in your code by referring to the name of the constant. Enumerations are a collection of related constants. An enumeration has a name, and it stores a numeric data type. Then inside the enumeration, you have a number of fields, each with a name and a value. So for example, you might create an enumeration for the months in the year. There are 12 of them, and so you might have an enumeration called months, and then one of the fields is January, one of the fields is February, etc. And those have values. Or you could do days of the week. Structs are user-defined data types. They're similar to enumerations in that they're a collection of values, but they can contain any data type. Enumerations contain numbers, and a struct can contain anything, including strings or date time. Let's go see a demo of constants, enumerations, and structs. I'm in the sample project, and here I've defined two constants, one for months in the year, one for days in the year. I use the const keyword to declare a constant, so I'm declaring a constant named months in year as an integer equal to the value of 12, and then I define another constant called days in year as an integer, which is equal to 365. And now in my code, I can reference months in year and days in year. I just need to remember what the constant's called. I don't have to remember what the value is. Let's look at a couple of enumerations. I have an enumeration here called calendar week, and it contains values for the various days in the week. Then there's an enumeration called work week, which has the same days, of course, but in a different order. So on the calendar, the first day of the week is Sunday, and the last day of the week is Saturday. But in the work week, the first day of the week is Monday, and the last day of the week is Sunday. So these two enumerations have the same fields, Sunday through Saturday. The fields have different values. And then to use these enumerations, I start with the name of the enumeration, calendar week or work week, and then when I press dot, I'll see a list of what's in there. So for example, if I say work week dot, there's a list of the fields in that enumeration. And if I want to get the integer value, I can cast these to an integer. Next up, we have a struct named author, and that struct has fields for first name, last name, company, and title. Then I create a variable called author1 using that struct as the data type, and then I can say author1.firstname, author1.lastname, and I can get IntelliSense help, company or first name, etc. I also create a second variable called author, which has the same fields, and then I can use those in code. Well, let's run this and step through what we just did. I'm going to press M to look at constants, enumerations, and structures. First, let's look at constants. I'll step into that code, define the two constants, months in year, which is equal to 12, days in year is equal to 365, and then I can use that in code and display the months and the days in the year. Next, we'll look at enumerations. I'll step into this code, and I want to display whatever the value of Sunday is in the calendar week enumeration, which of course is 1. And then on the next line, I'll display whatever the value of Sunday is in the work week. And when I do that, I get these results, that Sunday is day 1 in the calendar week and day 7 in the work week. And finally, let's look at using structs. I create two structs based on the author struct, which has first name, last name, company, and title name fields. I fill out the values of those fields. And now author 1 last name is Getz, first name is Ken, author 2 last name is Green, first name is Robert. And I can display that information. So constants are a way of storing values that don't change. Enumerations are a way of storing related constants. And structs are similar to enumerations, but you can store any data type. And in the author struct, we stored string. The role of operators is to perform an action on one or more values and then return the results. There are a number of operators. Arithmetic, to perform addition and subtraction. String operators, to change the value of a string. Assignment operators are used to assign a value to a variable. Comparison operators give you the ability to compare the value of two or more variables. Logical operators allow you to group expressions. And then type operators give you the ability to determine if a variable is of a certain type. Let's look at these in more detail. The arithmetic operators are used to perform basic math on one or more variables. Plus will add two numbers, or convert a negative number into a positive. Minus subtracts two numbers or converts positive to negative. Star multiplies two numbers and / divides them. The percent sign divides two numbers and returns only the remainder of the result. Plus plus increments a number by 1, and negative decrements a number by 1. The plus sign is a string operator, and that concatenates or adds two strings together and produces a new string. Assignment operators perform the same operations as arithmetic operators, but with less code. So plus equal adds two numbers together or converts a negative into a positive. So instead of saying variable 1 equals variable 1 plus 5, you can say variable 1 plus equals 5 and do less typing. Negative equal subtracts two numbers or converts positive to negative. Plus equal multiplies, / equals divides, and percent equals divides two numbers, returning only the remainder. Comparison operators are used to compare two values. Equal returns true if two values are equal. So the equal sign is an assignment operator. Two equal signs is a comparison operator. Exclamation mark equal returns true if the two values are not equal. Greater than returns true if the first value is greater than the second. Less than returns true if the first is less than the second. Greater than equal and less than equal. Logical operators are used to compare two expressions. A ampersand b returns true if both a and b are true. A pipe b returns true if either a or b is true. Exclamation mark a returns true if the expression in a is not true. A caret b, that caret is shift 6, this returns true if either a or b is true, but not both of them. A double ampersand b returns true if both a and b are true, but if a is not true, then b does not get evaluated. This is called short-circuiting. If a is not true, then both of them can't be true, and there's no reason evaluating b since a isn't true. A double pipe b returns true if either a or b is true, and if a is true, then b does not get evaluated. Type operators can be used to test whether an object is of a particular data type. So here, object 1 is defined as an object, and we store 7 in it. And then we want to know if object 1 contains an integer. So if object 1 is int, says, does the variable object 1 contain data of type integer? Let's go see a demo of these operators. I'm in the sample application, and let's take a look at arithmetic, string, comparison, logical, and type operators, and then look at operator precedence. We'll look at arithmetic operators first. And to do arithmetic, I'm going to create a variable called total amount. It's defined as a double, and it's equal to 100. And then the variable result will store the results of various arithmetic. I'm going to add 100 to the total amount, subtract 50, multiply it by 6, divide it by 17, and here are the results. Simple arithmetic giving us the results we expect. Next, I want to divide 17 into the total amount of 100 and use the percent sign operator to tell me what the remainder is. So total amount, percent sign 17, tells me that 17 divides into 100 x number of times, and the remainder is 15. I can do the same thing with a decimal. 17.5 divides into 100, winds up being 5 times, and the remainder is 12.5. We'll also use the plus plus and the minus minus to increment total amount by 1, and then decrement it by 1. We take 100, increment it by 1, that's 101. We take that amount, decrement it by 1, and we're back to 100. So those are arithmetic operators. Let's move on now and look at string operators. There's one string operator, that's the plus sign, and you use that to add strings together. So I'm going to create two variables, author1 and author2, and then we're going to create a third string variable called greeting by taking the contents of author1, which is Ken, adding the contents of author2, which is Robert, adding say hello, and the result is the greeting, Ken and Robert say hello. Let's now look at comparison operators. Comparison operators give us the ability to compare two variables. And those variables are integers. Number 1 is 100, number 2 is 200. And in the following code, number 1 is equal to number 2, that's an expression. And expressions return true or false. So the expression number 1 equals number 2 returns false. And I'm then going to display that result to the screen. So number 1 equals number 2, that returns false. In the next expression I ask, is number 1 not equal to number 2? That returns true. Is number 1 plus 200 greater than number 2? Is number 1 less than number 2 minus 100? Is number 1 greater than or equal to number 2? There we go. So, number 1 is 100, number 2 is 200. Are they equal? No. Are they not equal? That's true. Is 300 greater than 200? Yes. Is 100 less than 200 minus 100? No. Is 100 greater than or equal to 200? No. Is 100 less than or equal to 200? True. That's comparison operators. Logical operators give us the ability to combine expressions. So to do that, we're going to create 4 variables, number 1, 2, 3, and 4, those are integers, a couple of strings, Ken and Robert, and then a third string, we'll assign a value to that later. So here's an expression, number 1 less than number 2. That will evaluate to true or false. Number 3 less than number 4 is also an expression that will evaluate to true or false. The ampersand gives us the ability to say if this expression is true and this expression is true, then execute the code inside the block. The pipe is the OR, so we'll assign the value Robert to author and ask if author is equal to author1, which is not true, or author equals author2, which is true, then display the code in the block. The exclamation mark is the not. So here's an expression, number 1 greater than number 2, which is false. So if this expression is not true, then display this code. The double ampersand is a short-circuiting version of AND. So if author1 equals Andy, and also author2 equals Robert, then display this code. But author1 is not equal to Andy, so there's no way that both of these expressions can be true, and so the runtime does not even evaluate the second expression. The double pipe is the short-circuiting version of OR. If author1 equals Ken, or author2 equals Robert, then execute this code. Well, author1 is equal to Ken, so regardless of whether author2 is equal to Robert, one of these two expressions is true, so the runtime does not evaluate the second expression because it doesn't need to. So we use the ampersand to see if both expressions are true, the pipe to see if one or the other is true, the exclamation mark equal to see if an expression is not true, and then we saw the short-circuiting AND, the double ampersand, to see if two conditions were true. If the first is not true, no need to evaluate the second, and the double pipe, which is the short-circuiting version of OR, if the first expression is true, no need to evaluate the second. That's logical operators. Let's look at type operators. The type operator gives us the ability to ask questions about what's stored in an object. So object 1 is declared as an object. Let's now store an integer to it, and then we can ask if object 1 is int. In other words, is an integer stored in this object? And the answer is yes, that is an integer. Next, we'll store a decimal in there, and object 1 is decimal. Let's store a string to the object. Object 1 is string. And finally, let's store a float in there, and then use the getType method of the object to display the type of information stored in the object, and that is system.single. Finally, let's look at operator precedence. Let's define three integers: first amount, second amount, third amount. And then let's evaluate. So what does this line say? We've got three expressions in here: first amount greater than 50, second amount greater than 300, third amount less than 500. What order are these going to be evaluated in? Is it if the first amount is greater than 50, that's an expression, and also one of these two is true, second amount greater than 300 or third amount less than 500? Or will this be evaluated as follows? Here's an expression. If the first amount is greater than 50 and the second amount is greater than 300, or the third amount is less than 500, then the following is true. Two different ways of evaluating this. By default, the AND operator takes precedence over the OR. So the way this expression is evaluated is as the following. First, we evaluate if first amount is greater than 50, which it is. Then we evaluate if the second amount is greater than 300 or the third amount is less than 500, which is true. Scroll this down so you can see it. So by default, the AND operator takes precedence over the OR operator. Now, rather than remember operator precedence or have to look at a line of code and figure out what order things are being evaluated in, a good practice is to use parentheses to not only make your code more readable, but you can also then control the order that expressions get evaluated in. So in this example, we're using parentheses to identify the expressions we want evaluated. The parentheses around these two expressions will tell the runtime to treat this as one expression. If first amount is greater than 50 and second amount is greater than 300, which evaluates to false, or third amount is less than 500, which is true. So the first example, let's just scroll up so you can see it. First example by default looked at first amount greater than 50 first, and then evaluated second amount greater than 300 or third amount less than 500. In the second example, we changed that order using parentheses, and this is evaluated as following. If first amount is greater than 50 and the second amount is greater than 300, or the third amount is less than 500. So by using parentheses, we can control the precedence and also make our code more readable. So in this demo, you've seen using various operators and how you can control operator precedence using parentheses.